there's something called the Buckingham pi theorem, and this is another place it starts to get really, really deep. So basically, the deal is the world doesn't care about our unit system. The world behavior is not going to change. The behavior of pendulums, the behavior of cycles, of foxes and hares, are not going to change if we abolish the metric system and adopted, adopted unit systems based on imperial units again, or if we were to measure time in microseconds or whatever. It doesn't care. And in fact, any dimensionally homogeneous equation, any equation that is meaningful in terms of only adding consistent equations, can be re-expressed with a smaller equal number of dimensionless variables. Okay. And it turns out that often we will get a smaller number of variables. We could take our equations. We could take our agent-based model. We can take our system dynamics model, the stocks and flows. And we can come up, and those models have a certain number of parameters. And we can come up with a smaller number of parameters very often that are dimensionless parameters. And we can verify that as long as those dimensionless parameters have the same value, retain the same value, it doesn't matter what the value of the actual parameters, original parameters are. It's really what matters is the value of those dimensionless parameters. And then we can do calibration on those. We can do sensitivity analysis on those. We don't have to do them with all the original parameters. We can just do it with the dimensionless parameters. Okay? And moreover, it turns out that after calculating those, we can figure out how to build a scale model that exhibits comparable behavior, but with a much smaller population.